Here I've been asked to find the exact value of some compositions of trigonometric functions and inverse trigonometric functions with the order kind of switched up. Sometimes it's a trig function on the inside and an inverse trig function on the outside, and other times we have the inverse trig function on the inside and the trig function on the outside. But to start, we'll kind of approach them the same way, and we're going to work from the inside out. All right, so in the end, I'll take an inverse cosine of something, but for right now, I'm going to think about taking the sine of 5 pi over 6, because that's on the inside. All right, well, I always like to think about what angle I'm dealing with. 5 pi over 6 is over here. Sine's a y-coordinate, so sine of 5 pi over 6 is 1/2, and now I'm asked to find the inverse cosine of positive 1/2. All right, well, that's going to have to be a value over here in the first quadrant, and that's pi thirds, where cosine is equal to 1/2. So we started on the inside, and we worked our way out. We're going to take the same approach here, but this time I'm asked to evaluate an inverse cosine first. And here it's very important that I remember the range for inverse cosine. The range for inverse cosine is from 0 to pi, so I better be writing an angle down here that's between 0 and pi. Cosine is negative in quadrant number 2, so I'm looking for that angle right there, 5 pi over 6. All right, now I'm asked to find the sine of 5 pi over 6, and well, I already kind of done that in the first one, just thinking about how these two problems play, and I get 1/2. In problem number 3, I'm asked to find the inverse sine of root 2 over 2. It's nice when there's a positive thing in the inside of this inverse trig function. It lets me know that I'm going to be dealing with a first quadrant angle. Sine is equal to root 2 over 2 at pi over 4. And then the tangent of pi over 4 is 1. All right, so I get down to this fourth problem, and everything's been going very well, and I feel good about everything, but 11 pi tenths is not one of the values, angle values on my unit circle that I have memorized, right? It's not one of the ones that I can easily evaluate like 5 pi 6 is. So I have to think my way through this one a little differently, and if we were being very naive, we might think, well, inverse trig functions undo each other, so I'll just write down 11 pi tenths. But if I think about the range of inverse sine, my final answer here has to be an angle between minus pi halves and positive pi halves. And 11 pi tenths is out here just past pi, right? So if I thought about a number line, my answer should be between minus pi halves and positive pi halves, and 11 pi tenths is out here, right? So I'm looking for an angle in this region, and that can't be it. So we have to think our way through this. So I'm going to imagine where 11 pi over 10 is. Well, 10 pi over 10 would be pi, so 11 pi over 10 has to be this angle right here. And if I evaluated sine at that angle, well, I'd get a number. And what number would I get? Well, I don't know, but it's a y-coordinate, right? It's whatever the y-coordinate here on the unit circle is. Maybe it's some number I could call b. Well, there's one other place where sine has the same value, and it's over here in quadrant number 4. Now, my picture's not drawn to scale, and that's like the worst circle I think anyone's ever drawn. But if I think about reference angles, right, that was 11 pi over 10. The reference angle would be pi tenths. These two values have the same reference angle, and it must be this angle that I'm actually looking for, because inverse sine can give me positive angles in quadrant 1 or negative angles in quadrant 4. And since if I think about this sine inverse of whatever that number b is, well, it has to be that angle. And so not pi tenths, but since I'm rotating down into the fourth quadrant there, minus pi over 10. And there is our nice final answer.